AI revolution is underhyped. We need the energy.
Chinese scientists have reached a major milestone in the development of the country's artificial sun. They achieved a plasma operation for 1,066 seconds, a new world record.
America wants our land, our resources, our water, our country.
Well, we need Greenland for national security purposes.
We're telling Ukraine they have very valuable rare earth. They have great rare earth, and I want security of the rare earth.
What connects the dots? Do you have a feeling that some big game is happening behind the scenes, and all we see on the surface are just flashes of some absurd news that just a year ago were unthinkable?
Let me tell you, you don't have the cards. With us, you have the cards. But without us, you don't have any cards.
This is a poker game where everyone bluffs and tries to hide their true intention. But ultimately, as we will see from this video, everyone has the same goal: energy to power AI. But if that's a game, who holds the joker? Welcome. If this is your first time here, I'm Scripter, an AI researcher, a former Forbes columnist in China, and a sci-fi writer. And here on Scripter channel, we try to make sense of AI.
Anomaly detected.
This game is as old as life itself. Energy is a driving force of evolution. Every living being on this planet fights for it. We've all seen this classic scene: two trees battling over sunlight. And whoever reaches the light first shades the rival, dominates, and the opponent usually, well, disappears. Evolution. The same rule applies to animals, including humans, including groups of humans, like countries. Half of the conflicts and wars in history were caused by the fight for energy. And as humankind consumed more and more energy, competition has only grown fiercer. And then AI came, and the stakes went up. Here's what former Google CEO thinks about how much energy AI will need.
We need another 90 gigawatts of power. 90 gigawatts is 90 nuclear power plants in America.
But no matter how unthinkable the task of building 90 nuclear power stations in just 4 years is, there is something even more important behind these numbers. This chart shows us power consumption by AI. These are actual numbers. What we see is that the demand for AI is not linear, nor is it cubic. It is exponential. Only a few technologies of the past followed the exponential trajectory. That's computer chips, Moore's law, mobile phones, and internet data. And now, AI. AI is exponential. Energy comes in many forms. We pump oil, we plug in phones, we burn wood. But no matter what forms it takes, it all comes from one source, from one reaction. Two hydrogen nuclei fusing together and releasing energy. It's fusion, nuclear fusion. This happens inside every star, including our sun. The released energy radiates as sunlight, and trees and plants absorb it and store it. And when a tree dies, it turns into coal, natural gas, or oil. And then we extract it and burn it. That's an energy ladder. For centuries we burned wood. Then, with engines, we switched to coal, then to oil, and then to natural gas. Then we bypassed plants altogether by harnessing hydropower and wind, which are both powered by sunlight hitting Earth. And then we learned how to harvest sunlight directly with solar panels. Technological progress is nothing else but scrambling up the energy ladder, trying to get as close as possible to the source, to the sun, by skipping intermediaries. All those sources share the same flaw. They cannot scale exponentially. For example, if we want to build a gas station, first we need to locate and secure a deposit, lay pipelines, construct the plant, then expand the grid. Essentially, it's a decades-long process, which makes it linear. Our current energy supply is effectively linear. Do you see the problem? We have an exponential demand and linear supply. What's at stake? Well, soon we won't be able to power AI with traditional energy sources, fossil or renewable, doesn't matter. And whoever finds the solution for this problem wins the whole game. This is the largest game in town. For 70 years, humans have been trying to bypass the traditional energy sources, to climb to the top of the energy ladder, to fusion, to ignite an artificial sun. The sun runs on hydrogen, and one mid-sized car tank of liquid hydrogen could power for one day the entire planet. And here on Earth, we have virtually unlimited amount of hydrogen. Technically, our oceans are made of it. Once you have one artificial sun, it can then be copy-pasted as many times as you want. They don't need exploration or deposits or pipelines. Well, of course, you still need to manufacture the fusion power plant. But once a supply chain is set, the rest is copy-paste. Which is why, among all sources of power, only fusion, an artificial sun, can match the exponential demand for AI. The first news came in 2017. China beat the world record by maintaining fusion for 101 seconds. Back then, completely unthinkable. China's success awakened American technological giants and fusion startups mushroomed. In 2021, CFS, which is an MIT spin-off, unveiled a new magnet that could make an artificial sun much smaller and cheaper than the Chinese version. They raised $2 billion, and as of now, CFS is the most advanced American fusion company. Their goal? To ignite the artificial sun sooner than China does. China was not wasting time. 2023, 403 seconds of fusion. Then, in January this year, 2025, 1066 seconds. And then finally, on May 5th, just 2 weeks ago, the big news came. Let me translate. China is finishing work on their net gain tokamak. When delivered, this will become the world's first fully operational artificial sun. And the key word here is finishing. Because we learned from the news that China is actually, the tokamak is in final stage. Delivery date, 2027, which is just 2 years from now. It is practically ready. The AI fusion race is getting close to its culmination. The question is, can the US catch up? And this is where the Joker comes into play. This is niobium, atomic number 41. Niobium is a critical element of low-temperature superconducting magnets, the ones that are used in old-school fusion tokamaks, like the ones that China built. Basically, we can think of niobium as the most important component of the Chinese fusion program. Which is why, over the last decade, China was relentlessly securing sources of niobium all over the world. Which was not very difficult to do, because it turns out that there are only 3 producers of niobium in the world. 2 of them in Brazil and 1 in Canada. And China directly owns one of them, the one in Brazil, and indirectly owns the second one through a mixed combination of financial and political controls. Altogether, China controls more than 90% of the supply of niobium in the world. China has successfully secured the most essential material that is needed to build fusion program and to power AI.
Anomaly detected.
Meet yttrium. It is a rare earth metal, and it is a core element of the new generation of tokamaks that American CFS is building. It is much stronger than niobium, which is why the American tokamaks are supposed to be much smaller and powerful and cheaper than the Chinese ones. In other words, yttrium is the core element, core ingredient of American fusion. Yttrium, just like any other rare earth metals, is actually not that rare. However, it is extremely difficult to extract and refine. One country has been working very hard on developing technologies for yttrium refining. And as a result, by now, this country has become a de facto world monopoly in yttrium production. And that country is China. Yes, you heard it right. The material that the most advanced American fusion project completely depends on is controlled by China. That's a joker. Even if America ignites their artificial sun before China ignites theirs in 2027, the question is, can America scale? In other words, can they produce more than just a prototype? And now the cherry on top. Out of 118 elements in the periodic table, these two became the keys to the AI fusion race: niobium and yttrium. Let's take a look at the map. Let's see where the largest deposits of yttrium and niobium are located. Besides the already operating mines in China and Brazil, the biggest deposits of yttrium and niobium are in Canada, Greenland, and, as we've recently learned, Ukraine.
America wants our land, our resources, our water, our country.
Well, we need Greenland for national security purposes.
We're telling Ukraine they have very valuable rare earth. They have great rare earth, and I want security of the rare earth. Tell you, you don't have the cards. With us, you have the cards. But without us, you don't have any cards.
This is a poker game where everyone bluffs and tries to hide their true intention. The largest game on the planet is now in full swing. And the stakes are AI and the New World Order.
Anomaly detected.
If you enjoyed this video and you want more, like, subscribe, and also don't forget to subscribe to our newsletter, Scripture newsletter, so you don't miss anything important. Alright, and now we got to our secret section. The one thing that I wanted to talk about today is what if we are wrong? Basically, our entire video is based on one assumption, that AI energy demand is going to grow exponentially. And although it is actually, I think, intuitively certain that the demand for AI compute, so the number of actual intelligence, will be growing exponentially. This is for sure, this is certain. It doesn't really necessarily mean that demand for AI energy will grow exponentially. And the obvious reason is just with time, energy efficiency of AI will be improving, just like it did with computers, for example. And we already see this happening. With one of the examples is distillation, which is a new way of training the model that takes like 10 times less energy to train. Another example would be a mixture of experts or other different technologies that basically shut down parts of the AI models so it doesn't consume energy. It's pretty much the same way how nature optimize energy consumption in our brain. Our brain is not fully running all the time like most of current AI models do. Instead, brain shuts down parts of it. Brain, most of the time, most of the parts of the brain are actually idle. That's how nature does it. And it's pretty certain that AI going to be improving on that front as well, the energy efficiency. But what I think the most important thing that can basically change the whole equation is when AI flywheel will come into motion. And let me explain what this means. A flywheel is a concept that we have seen in quite a few other technologies that like breakthrough technologies. What happens there is once a revolutionary technology appears, it begins to get talent and funding, and it gets a momentum where that technology is actually begin to recreate itself and becomes better and better and better. Example with computers. Better and better computers appeared, and they were actually enabling even better computers. Of course, it was very slow, but nevertheless, it was a flywheel. And the thing about this flywheel is that once you own it, it is very hard to compete with for competitors to do anything about it, just because this flywheel, each next technology enables even better technology, and it keeps going and it keeps going, and whoever is left behind, they're left behind, and we never heard about them. The thing is, the same concept is about to start with AI. It's probably already in motion, but I think we're going to see it accelerating, and it's going to be way more dramatic than computers. Basically, AI is inventing AI. This is an AI flywheel. And one of the examples is actually especially astounding. Almost all tokamaks, fusion tokamaks, they use magnets, superconducting magnets. That's where they actually using niobium or yttrium. The thing about it, they become operational only at a very low temperature. So you have to cool them down. And to do that, it's actually extremely non-trivial task. And the way how it is done is that you almost like have a nested fridges one into another. It's like a Russian doll with fridges. You use one fridge with nitrogen, liquid nitrogen, and use that to cool down liquid helium. And then you use that liquid helium, which is much colder thing, to cool the magnets. So it's like nested fridges, extremely complex and very expensive thing. And that's what was used for niobium. That's what the Chinese are using, and also ITER, based on the same technology. Extremely complex. Well, it's kind of time proven because people have been doing this for many years. They know how to do it, but it's extremely expensive. And that's what Americans, CFS did. They figure out that if you use Yttrium, it's actually, you don't need to, Yttrium is getting superconducting at a slightly higher temperature, but the importance is that you don't need helium anymore. So instead of using three nested Russian fridges, you kind of just two is enough, basically, or even one may be enough. Simplifies the whole thing dramatically. So here's what I want to say. How this the AI flywheel comes into play. The thing is that the harsh reality is that we don't really know why superconductivity happens in these metals. Yeah, there are books, tons of books are written about it, but if you dive deep very quickly and you ask a question, why, very quickly you will bump into the wall that will say, oh, and that's just quantum mechanics, that's it. That's just another way to say we don't know. The reality is that we do not know why these materials are becoming superconducting at that specific temperature. And that's a core technology for fusion. Well, and now we know for AI as well. And basically, we don't know why it is happening this way. And the way how it is currently done is that there are multiple teams around the world that are actually looking for these new materials that are superconducting, becoming superconducting at a higher and higher critical temperature. So you don't have to cool them so much. And the way how they do it manually. It's a trial and error. They just put together different materials, and they, of course, it's a huge oversimplification, but the general idea works like this. They just try different materials. It's like enormous combinations of different alloys and combinations of everything. And the thing is, so far they haven't been very successful. And the thing is, this is exactly the task that AI can do better than anybody. Because it is very possible that in reality, there is a combination, combinations that we don't know yet, where this whole thing can happen like almost like at room temperature. Example would be here that the chemical reaction with ammonia, right, where you have nitrogen and hydrogen merging together in the presence of iron. It's like catalytic reaction, and it was found by chance. So what if the same thing, the catalytic reaction, can actually happen with superconducting magnets? And nobody can find that better than AI can. The point is, this is AI flywheel. This is an example where AI can actually enable a much more powerful version of itself. Basically, can create an unlimited supply of energy that you don't really need this tokamak anymore. You don't need to build this whole thing that we have seen on the video. All you need is just a small thing that work at temperature. It's like, it may become like a home appliance. And that's AI flywheel. And if it comes into motion, when it comes into motion, the whole thing, these equations, this expectations analysis that we're doing, probably will go into the garbage bin because everything will be rewritten. So that's where we can be wrong. All right, guys, thank you for being with me. It was fun. We'll see you on the other side.
Anomaly detected.
If you like stories and ideas like this, you may like my new sci-fi thriller, Scripter. It got published last month. I have a copy here. Available on Amazon. You can have it as a paperback. It will be delivered to your door, or as an ebook on your Kindle. Actually, I'm very keen to hear what you think about this story.